All right. So guys, the first thing again that we are going to talk about today is how to light a Bunsen burner. And this is the only one of these 6 things that I'm actually going to give you steps. Because guys, this is going to be one of the hardest things you do in this class. And it's actually fun for me to watch you struggle with it. So don't be surprised when you get into lab. If you can't get your Bunsen burner to light, you will probably find me laughing at you. But quickly you'll figure out how to do this and it gets better. But it's one of the great delights of my life to watch you struggle. So guys, this is how to light a Bunsen burner. You ready? First of all, let me introduce you to a Bunsen burner. So guys, this is a Bunsen burner. This is going to be our heat source for the year. We use this to heat chemicals, boil water, things like that. Here's the way this thing works. Coming in the right-hand side, the left to you, coming in the left-hand side is where the natural gas enters the burner. Then guys, what you're going to see that the natural gas, as it enters the burner, it actually takes a sharp turn and it goes vertically through this little hole that we call a jet. So when the gas goes in, it goes like this and then it goes up. And when it hits this jet, this constriction, it accelerates. It's kind of like the nozzle at the end of a garden hose. That constriction causes that gas to accelerate and rush up. Now guys, in the bottom of a Bunsen burner, you actually have what is called a needle valve. This needle valve, as you might expect, has a little needle at the end, and that needle clogs the jet and shuts off the gas. Then the last part of this that you need to understand is that this part, the barrel, which is where the gas goes after it leaves the jet, it actually has slots cut in the side. And the way that this works is that when the gas goes accelerating up the barrel, it creates a vacuum and it sucks air into the barrel, and the air and the gas mix inside the barrel and then they combust up here. If any of you know how a lawnmower engine works, this is kind of like a carburetor. It's the place where the air and the fuel mix. So this is how you light a Bunsen burner. You ready? Here are the steps. Step number 1, shut it down. So guys, what does that mean? Shut it down. Well, what that means is you are going to screw the needle valve all the way shut. And guys, do not be afraid to handle these things. Pick them up. So pick it up and screw the needle valve all the way down and then screw the barrel all the way shut. So you are going to shut it down. Now, guys, understand you're not going to disconnect the Bunsen burner from the gas. So it'll be like this. And you're going to have this thing like so. And now we've got the entire burner shut down. Now, guys, step number 2 is turn on the gas. Step 1, shut it down. Step 2, turn on the gas. Now, guys, let me introduce you to our gas taps. They're up on our countertops. Yours are actually horizontal. Mine are vertical, doesn't matter. The deal is this. The gas tap has a schnozzle to which the hose is connected. When the handle is perpendicular to the schnozzle, it's shut off. So this is off and this is off. This is on. So you will turn on the gas. But guys, why is the gas not flowing? You close down the needle valve. So now step 3 is open the valve. Open the needle valve. And so you pick this up, and guys, again, don't pick these up. Don't try to do this all in the so pick this thing up, open up the valve. Can you hear that? Open the valve until the gas starts to hiss. Okay? Now, at this point, I'm going to turn this off. You won't do that, but I'm going to turn this off because we're going to fill the room with gas as I teach you how to do this next thing. So guys, the next step, step 4, is it step 4? Light the burner. This is the part that you're going to struggle with. So guys, when you light your burner, you will not use matches. Because if you light it with matches, you throw the match in the trash, and then we have a trash can fire. You will use this. This is what is called a striker. And you will use this to light your Bunsen burner. Now guys, here's the problem. To get the burner to light, you need sparks. But you'll notice that if you do this, this thing will not spark and you will spend a day trying to get your Bunsen burner to light. So this is how you use a striker. You ready? You need a left-handed gun. You don't need to write any of this down. You'll remember, you need a left-handed gun. Understand that a right-handed gun does not work with these strikers. You need a left-handed gun, but it's got to be a gangsta gun. Okay, so you got to turn it sideways. So you're going to grab your left-handed gangsta gun, and you are going to put the hood of the striker against the barrel of your left-handed gangsta gun. Then you're going to hook your thumb, the hammer, on this arm of the striker, and you are going to pinch so hard that it leaves a crease in the hammer of your gangsta gun. Okay, so left-handed gangsta gun, this against the barrel, hook it here, and then when you're squeezing hard, you're then going to push this across. Oh my gosh. And it makes all sorts of sparks. Get the idea? That's what you're going to do to the Bunsen burner. So we're back here. We've got our left-handed gangsta gun. Hook this on here. Hold this over the burner. And there you go. Yeah. I know, right? For some of you, this will be an amazing victory to just get this far. Now guys, here's the problem. This flame will never boil water. This flame will never cook chemicals. This is a very low efficiency flame. What is it that tells you that it's a low efficiency flame? It is yellow and flickering. This is wonderful if you want to cook marshmallows, but it does not work in a chemistry class. So now, are we on step 5? Okay, now on step 5, the next step, and let me get you some lights, is adjust the flame. And so guys, let me give you some sub-thoughts there. As you're adjusting the flame, here's the deal. The valve, just write down valve equals size. And then write down barrel equals heat. So guys, here's the way this goes. When you adjust this flame, the first thing that you want to do is understand this flame is way too big. So you need to make it smaller. So what's going to make this smaller? The barrel or the valve? The valve. So you're going to pick this up. Guys, again, don't be afraid to pick these up. And you're going to grab it underneath and you are going to adjust the valve. And realize if you go the wrong way, it's just going to get bigger. So you want to adjust the valve until the flame is about what? 4 inches? About 4 inches high. So now we've got an appropriate sized flame. The problem is it's not hot enough. So now we need to add some air to the mixture to allow this to combust more efficiently. So what you're going to do is this. Pick this thing up, and now you're going to adjust the barrel. Now guys, you got to be careful. Do not grab the barrel at the top because it will brand you. It's really hot. So grab the barrel at the bottom and twist. And guys, as I twist, look at what happens. The flame actually goes from yellow and flickering to tight and roaring. And guys, what we've done in opening up the barrel is now these vents are open and the air can get in and it mixes and causes it to burn more efficiently. Now guys, let me show you the goal. When you do this right, and can you see that this flame has like 2 parts? There's an outer part that's like violet and then the inner part that's blue. You want to focus on the inner blue part of the flame, and you want that flame to be about 1 inch to 1.5 inches tall. So this is a little too short. So I'm going to come down here and I'm going to give it more gas. But as I give it more gas, I may also need to give it more air. And guys, eventually, that's the flame I'm looking for, where you've got that inner blue part of the flame that's about 1 inch tall. Get the idea? Okay, then guys, and I forgot to grab one of these. Then what you need to do is set up your ring stand to take advantage of this. And so guys, and make sure you do this before you put the burner on the ring stand, or you're going to get hurt. Because what you want to do now is put the Bunsen burner on your ring stand, and you want to adjust the ring so that the ring is even with the hottest part of the flame, that inner blue flame. Then you put this on here and you're ready to go. Guys, don't make the mistake of having this like way up here and then you put that there, because that metal will get hot, but there isn't enough heat there to boil water or something like that. And then when you realize you've got to adjust this, it's so stinking hot you can't touch it. So guys, just get in the habit that as soon as you put the burner here, you move this up or down, you get it adjusted just right, set this here, and you're ready to go. You get the idea? Okay, now the last step, is it 6 or 7? 6, shut it off. But guys, here's the trick. The needle valve at the bottom of the Bunsen burner is not actually gas tight. If you shut this off by turning off the needle valve, it will actually leak and fill our lab with gas. So when you shut it off, you always shut it off at the tap and not at the burner. All right. So there you have it. Bunsen burner 101. You guys good? All right. So guys, we're now ready to move along. Let me get this out of the way. I can just do this. That's not going to be hot. Okay. And guys, understand everything that I'm showing you right now, you are going to be doing in lab on Thursday. So just be ready for that. Okay, so guys, the next thing that we need to talk about is how, and you're probably going to run and put this in your notes, tear and operate a balance. So guys, these are the balances that you will be using in this lab. They weigh up to 200 grams and they weigh down to hundredths. They're actually pretty good balances, given that we have one at each station, and they cost about $300. So there's $2,500 worth of balances over in lab. It's nice that you have your own at your station. So guys, you've got to figure out how to make this thing sing and how to use it to measure mass. So guys, in order to do that, what I'm going to do is, rather than show you, I'm going to show you a video, and I'll try to highlight the important stuff as we go.
The electronic balances that we have are a wonderful piece of equipment to help us measure masses very quickly and very accurately. However, they're often one of the biggest sources of error in labs, mostly because of the misuse of the tare button. The weighing dish.
Sorry about the audio. We're okay though. So guys, he's going to introduce this idea of the tare button. Maybe we should put this in your notes so you know what it means. So tare is T-A-R-E. And next to it, you can just write re-zero. Guys, the tare button is the re-zero button on a balance. So how do we take advantage of it? Check it out.
It's located right here on these particular balances. And what it does, it basically subtracts whatever's on the balance. Right now, you can see that the balance reads 0. If I put an object on the balance, such as this beaker, we can see that the mass has changed. If I hit the tare button, that subtracts it, and now you see the mass still reads 0, even though there's something on the balance. Now, if I want to know the mass of the beaker, I want to make sure that it says 0 before I put the beaker on. So I would hit tare. Now it says 0. Now I'll put the beaker on, and I'll have the mass of the beaker.
So guys, important take-home message. Anytime you touch a balance, always tare it first. I don't know if you'll just remember that. You may want to put it in your notes. Guys, always tare a balance before you touch it, because the person that used it before may have messed up the 0 point. You always tare a balance before you use it.
If I then were to put an object in it, as is, now I have the mass of the beaker and the substance that is in the beaker. I have both. However, many times in lab, we're not interested in the mass of the beaker or the mass of the weighing dish. We're interested just of the mass of the chemical that we're putting in it. So, for example, if I have some sugar,
does this sound kind of like that homework question number 3 from the other day? A beaker and sugar. Oh gosh, my control thing went away.
and now you see the mass still. Now it says 0. Now I'll put the beaker on, and I'll have the mass of the beaker. If I then were to put an object in it, as is, now I have the mass of the beaker and the substance that is in the beaker. I have both. However, many times in lab, we're not interested in the mass of the beaker or the mass of the weighing dish. We're interested just of the mass of the chemical that we're putting in it. So, for example, if I have some sugar, and I want to know what mass of sugar that I'm using, I'll obviously need to put something down. I never will put a chemical directly on the pan.
Did you guys catch that? That's important. Never put chemicals directly on a balance. If you can't remember that, you may want to include it in your notes. Guys, never put chemicals directly on the balance.
So I'll need either a beaker or a weighing dish.
Guys, a lot of the times what we'll use is the thing he's got on the balance right there, which is called a weighing dish or a weighing boat. They're disposable little plastic trays that we'll use to protect the balances.
Such as this one. I'll put that down. Now right now it's showing me the mass of the weighing dish, 1.47 grams. If I add the sugar to it, that'll be the mass of the sugar and the weighing dish. But I don't want the weighing dish, so I can hit the tare button. That'll subtract the weighing dish, and now I can pour the sugar in, and the mass that it's giving me now, 5.69 grams, is simply the mass of the sugar. So the big thing to remember when you're using the balance is you want the balance to say 0 before you put whatever you're measuring. Okay?
Does that make sense? You guys good with balances? All right. So now let's see if we can hit this. Okay, so guys, we're good then with the way the electronic balances work. That will allow you to measure mass. But another thing that you're going to need to be able to measure in lab is not mass, it's volume. And you may remember from when we did lab checkout last time, you have a volume measuring device which is called a graduated cylinder. Now guys, in order to use a graduated cylinder well, there are 2 terms that you need to understand that are up here on the board, and I would encourage you to write them down. Those 2 terms are meniscus and parallax. I would include them in your notes unless you already know what they mean, but let's define them if you don't. Guys, meniscus is actually the concave up surface that exists on a liquid when it's in a cylinder. Some of you from biology understand capillary action, and the idea is that when you put especially water in a cylinder, the water is drawn up the sides of the cylinder, and that makes the surface of the water dipped. That dip is called the meniscus. And then guys, when you're doing this, when you're reading a graduated cylinder, you always want to cut down on what is called parallax. And parallax is error in a measurement caused by misalignment. And I'll show you what that means in just a moment. Can I go? Are you guys okay? Not yet? Okay, that's fine. How about now? Okay, so guys, graduated cylinder 101, here we go. So first of all, as we take a look at the still of this, you'll notice that this is the cutout of a it's a zoom in on a graduated cylinder. And you see this, right? Here's the dip at the surface of the liquid. What do we call that? The meniscus. Now here's the question. What do we do with the meniscus? And this isn't in your notes yet, but it needs to be next to meniscus in just a second. So guys, when we read the volume off of a graduated cylinder, do we read from the bottom of the meniscus, the top of the meniscus, the middle? Do any of you know the answer? It's the bottom. Guys, you will always measure from the bottom of the meniscus. If you can't remember that, write it down. When you measure volumes in a graduated cylinder, you will always measure from the bottom of the meniscus. Now, guys, let's mention one other thing really quickly before we get into this too deeply, and make sure that you're clear on this. And this has been in your homework for the last couple days. Guys, when you make a measurement, what's the rule for estimating when you record that measurement? 1 decimal place past the scale of the device. So, guys, let's talk. So we know that this graduated cylinder, and let me zoom in some more. We know that this graduated cylinder is graduated in whole milliliters. That's too far. That's blurry. So we know that the graduated cylinder is graduated in whole milliliters. So here's a milliliter, and then that milliliter has 10 lines between it. So the scale of this device is tenths of a milliliter. So what are you going to write down when you make your measurement? Hundredths of a milliliter. So here's how this goes. This is 8.1, 8.2, 8.3. Well, actually, no, I missed one. 1, 2, 3, 4, 8.5. So that is 8.6.
How to read a graduated cylinder.
Oh, poop. Why did that start? Sorry, guys. I know. I got to figure out how to shut this off because it's a huge pain in the butt. So, guys, here's the way that this works. This line right here is 8.6. But I would argue that this is a little bit below 8.6. So you can see that the bottom of the meniscus is a little bit below the 8.6 line. So if I were recording this data, I would put 8.59 to show that it's a little bit below 8.6. Now, what if you disagreed and you said that that was right on 8.6? What would you record as your data? 8.60. And guys, here's the deal. If you don't put the 0, your data is not okay. And I'm going to mark it wrong. For the rest of the year, I'm going to hold you accountable for this idea that you will always estimate past one decimal place past the accuracy of the device. So with this device, you've got to have a digit in the hundredths place, the hundredths place. So there you have it. Okay, so we've got meniscus, we've got parallax, and let's take a look.
Okay, how to read a graduated cylinder. We've got a 10 milliliter graduated cylinder here, and the first step we need to do is determine where our marks lie. We have a numbered mark of 8 here, and we have a numbered mark of 9. We have unnumbered marks between 8 and 9 valued at 0.1. In order to go from 8 to 9, we would go 8.1, 8.2, etc. up to 9. So we know for certain that this liquid has a volume somewhere between 8.5 and 8.6. The last digit we record is our estimated digit or uncertain digit. How far between 8.5 and 8.6 does this measurement lie? To determine that, you want to get your eye at the level of the meniscus, which is the bottom of the curved surface.
So guys, let's talk about that, because she not only talked about the meniscus, she also talked about this idea of getting your eye level. So here's the deal. When you are reading a volume from a graduated cylinder, and this will make more sense if I give you a real world example. If I wanted to find the volume of this water, we understand that there's the meniscus, and now you understand you measure from the bottom. But what's wrong with this if I'm trying to make this reading? It's unaligned. I can see the bottom of the meniscus, but if I'm reading at an angle, I'm not going to be able to get accurate data. So what do I need to do? We've got to get level, right? And what does getting level cut down on? It's the word you wrote down on your notes. Parallax. So guys, you've got two choices. You can either pick up the graduated cylinder or you can drop your butt. My suggestion would be drop your butt, because if you do this, you're shaking a little bit and you're not going to get a good reading. So you want to put the graduated cylinder on a solid surface, and then you want to drop your butt and you want to get down here so that you can see and get a good reading. So guys, how do you know if you've cut down on parallax and you are level with the measurement? Well guys, here's how. Every 10, so here and here and here, every 10th line goes all the way around the graduated cylinder. How does that help you? Exactly. If you are lined up, you won't be able to see that line twice. You know what I'm saying? If you're lined up properly, you'll see it in front, and then the line behind it will be hidden by the line in front, and that's how they give you the way of cutting down on parallax. You get the idea? Okay, so back to the video. Again, guys, these are all things you're doing in lab on Thursday.
And you need, as the scientist, as the observer, you need to determine how far between 8.5 and 8.6 the bottom of the meniscus lies. I'm going to estimate it to be 8.56.
I couldn't imagine her being more wrong, but you get the idea, right? We okay? All right. So guys, going back then, here's where we are. You know how to use a balance, you know how to use a graduated cylinder, you know how to run a Bunsen burner. You guys good? Okay. So now guys, the next two things that we're going to talk about are dispensing processes. Number 4 is dispensing solids. Guys, there's one thing I want you to write down under dispensing solids. And you can write this down however you want, but the bottom line is this. Don't contaminate Knappenberger's chemicals. Feel free to paraphrase. Guys, you're going to find out that everything that you are about to learn about dispensing is all about cleanliness, keeping from contaminating chemicals. So let me grab a spatula. Let me grab some solid chemical. And guys, we're going to watch a video to drive this home, but we're going to stop this and talk along the way. All of this is about avoiding contamination. Here you go.
When you're trying to measure out a desired mass of a chemical, it's important that you don't put too much of the chemical. Let's say I was measuring 2 grams of sugar. Well, I would first use a beaker or a weighing dish, put that on. Now I don't want the mass of that dish, so I'll hit the tare button. So it says 0. And now I want to put 2 grams of sugar in. Now it's very important that I don't go over, because remember, as soon as that chemical hits another container, I consider it contaminated.
You guys got that? As soon as a chemical leaves the stock bottle and hits another container, it is contaminated. What that means, guys, is it never goes back. If I ever see you put something into a weighing dish on a balance and you get too much and you pour it back into the stock bottle, I will take you out at the knees. Because guys, what that means is you have just ruined an entire stock bottle full of chemicals. We can't use it anymore because we don't know what was in here, so you just contaminated all of this. So guys, the bottom line, and if you can't keep this straight, you may want to write it down, never pour back into a stock bottle, ever. Never put stuff back into a stock bottle. So let's keep going.
So if I put more than 2 grams in, I can't just scoop it out and put it back in this bottle. We want to keep these bottles pure. So what we want to try to do is to ease up to that 2 grams without going over. So I'll use my spatula to put a certain amount in. Now, I might not know how much of this looks like 2 grams. So if I just dump this whole thing in, I might go over. And if I just dump it this way, I don't have very good control of how well it flows into the dish. And it might go nothing, nothing, and then all at once. And so what I use is what I call the tap method.
Hey guys, this really works.
To allow this. Notice if I just slowly tap on this spatula, notice that it just slowly puts an even amount in. Now if I want 2 grams, I can watch the balance there and get an idea that I'm not very close yet. And so I'm going to need about another one of those scoopfuls. And notice I'll, again, just lightly tap on this, making sure all of the sugar, in this case, goes in the pan. And I can just slowly watch it ease up to my 2 grams. I have very good control. I can just get a couple grains at a time in this way. And we'll just slowly ease up to 2 grams.
Okay, so guys, let's talk
at a time in this way.
Say that you get to this point, and you get to the point where, let's say you get exactly 2 grams. What are you going to do with the additional chemical that's on your spoon? And the answer is, you can put it back, because you will not be using your spoons to do this. We will be using spoons that have only been in that particular chemical, and they'll be attached to the bottle. So if you're reaching into a bottle with a spoon that is attached to that bottle, you can trust that this is clean, and any remaining chemical that's on the spoon, you can put back in the bottle. Now, what about this? What if he got more than 2 grams? What do you do with the additional chemical? Throw it away. So guys, if you get more than you need, again, once it touches that container, it's contaminated. We don't consider the spoons to contaminate, but that's contaminated. So if you get too much, guys, put it in the trash. But don't do this. Don't take the spoon and scoop it out, because now you've contaminated the spoon. So if you get too much and you need to get rid of it, you can either scoop it out with your spoon, or you can just take the dish over to the trash and tap some out of the dish. But that's the trick, guys. As soon as it touches that dish, it's contaminated and you can't put it back. You get the idea? Okay, so now the last one, and there isn't a video for this one. So guys, the last thing that we need to talk about is this. Actually the last 3. How do you dispense liquids? And guys, I'm going to show you how to do this 2 different ways. One is by pouring and the other is by transferring. And I'll show you the difference as we go. So guys, we're going to do pouring first. So here's the way this goes down. So this won't be the case for this lab, but it will actually be the case for the second lab we do this year. So when you go into lab, remember the island up front where I was standing and showing you around? That's the stock table. That's where you go to get your chemicals. So you're doing the lab, and this particular lab says that you need some ethanol. And so you come up here and you read the bottle, and this says ethanol, so you know that this is the stuff that you need. So you come up here and you grab your graduated cylinder and you get your ethanol and you go off on your way. And then later in the lab, it says that you need some of whatever this chemical is. So you take the lid off of this and you get some of what you need there, and you walk away and you've got all your stuff and the lab is going great. And then at the end of the day, and guys, understand it's not my responsibility to keep the front table clean. So somebody steps up here and cleans up the table, and all of a sudden we've got a really big problem. You see the problem? What's the problem? You don't know which lid goes with which bottle. Obviously here it's obvious because they can't get crossed. But guys, when I set out chemicals, most of the time they're in identical bottles. And because we don't know which lid goes with which bottle, what happens if we get them crossed up? We contaminated our chemicals. So guys, here's the way you pour. You ready? Do this every time. The bottom line is this: there will never be a lid on the countertop. If I look over at the countertop and if I see a lid on the countertop, I'm going to find who's got that bottle in their hand, and we're going to have a little chat. Guys, you never set down lids. So say, for example, we need some of this ethyl alcohol. Here's what you do. You take the lid off the bottle and you stick it in the palm of your dominant hand. You may in your notes want to write down palm the lid. This is the trick. Guys, you palm the lid to the bottle. So here's what you do. You put the lid in the palm of your hand, and then you grab the bottle and trap the lid between your hand and the bottle. Now you can get whatever you need, you can pour this out, and then when you're done with that, all you got to do is screw the lid back on and you're done. That way you never set the lids down and we never get them crossed up. So guys, just remember, always palm your lids. Does that make sense? Okay. Now guys, what about this? Graduated cylinders work really, really well if you need large volumes of liquids, 5, 10, 20, 50 milliliters. But what if you need a very small volume of a liquid? Like this one doesn't even go down to 0. So how can we measure 1 milliliter of liquid? And guys, the answer is this. This is what is called a transfer pipette. These are disposable, but what you will find is if we need to measure small volumes, this will actually be attached to the bottle that we're needing to dispense out of. So we'll switch to this bottle. So say for example, you need 1 milliliter of this stuff. Here's how you do it. You screw off the lid and set it down. You screw off the lid and you palm it in your hand. And then guys, what you're going to do, and let me just tell you. So this has graduations on it. This is 1/4, 1/2, 3/4, and 1 milliliter. So to use this, what you do is you smush the bulb, stick it in here. We're not worried about contamination because this is the only place this dropper ever goes, and you let go. And you slurp this thing all the way full. This is just water. You slurp it all the way full so the bulb has got some of the liquid in it, and then you put this back, drip, 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 until the meniscus is sitting on that 1 milliliter line. At that point, you let go. And what it does is it slurps that 1 milliliter of liquid up inside of the pipette, and then you can put this wherever you need it. You put it in your beaker, whatever you need to do, and then you just put this back and you're good to go. You get the idea? Okay. Guys, one last thing to do and we are all done. During lab on Thursday, well, we're done with the lab stuff. On Thursday, you are actually going to be using a funnel and a filter to separate a solid from a solution. Now guys, in order to do that, you're going to need filter paper. So I'm going to show you how this works. You may want to write down the steps. So this is how you use a filter. So you see the filter paper is a circle, right? This is going to feel a lot like kindergarten where you folded up paper and cut it out and made snowflakes. So what you're going to do, guys, is you're going to fold the paper in half. Just write fold in half. Step number 2, repeat. So now it's folded into fourths. Now guys, here's what you're going to do. Step 3, you can just write this down. Clip a corner. Step number 3 is clip a corner. Here's what I mean by that. You'll notice, guys, that when this is folded into fourths, right, you've got these 2 corners that are identical to each other. And what you're going to do is you're going to grab one of those corners and you're going to rip it off. Just throw it away. So you're going to take one of these corners and you're going to rip it off. But guys, don't clip this corner. Don't clip the corner where the big fold is. Clip this corner. Then what you're going to do, this is the next step, is open it up. And guys, here's the way this works. Obviously, if you stick your finger where there's 2 folds on top and 1 fold on the bottom, it's just going to unfold. What you want to do is you want to do this so that you get it so that there is 1 and 3. And guys, when you get this 1 and 3 set up, you want the 3 part to be the clipped corner. And then when you open this up, oh my gosh, it makes a funnel. And then what you can do is you can put this in your funnel and it has exactly the right slope so it fits in your funnel. But guys, the problem is this. When you do that and you let go, it pops back out. So what can you do to keep it in place? Get it wet. So guys, all you've got to do is come along, add a little bit of water, and there you go. And now your filter paper is stuck in your funnel and you can use this to filter stuff. The trick is that when you do that, as you're pouring stuff through this, do not allow the liquid to get higher than the filter paper or else it'll run around the edges and it's not actually being filtered. Get the idea? Okay, so guys, there are the 6 things you need to be able to do in lab. How do we do? You okay? Okay, so now guys, we need about 5 minutes to talk about a little bit of math and then we're done. So again, these are the 6 things that you are going to be doing in lab on Thursday. But guys, along the way, you are, and this is the next topic in your notes, significant digits and calculations. Along the way, you're going to be collecting data. And what does it mean to you when I tell you we're collecting quantitative data? Will it be measurements or descriptions? Measurements. And when you collect this quantitative data, you are then going to analyze this data by doing calculations. Now guys, here's the trick. When you do calculations, you've got to keep track of significant digits. I know that many of you know this, but I need to make sure all of you know it. There are rules for how many significant digits go in your answers, given how many significant digits are in your setups. These are the rules: multiplication and division. So guys, when you are multiplying and dividing, the bottom line is this. You get as many significant digits in your answer as the least accurate number in the calculation. So you look at the setup, you count significant digits. Whichever number has the fewest significant digits, that's how many you get in your answer. I think most of you knew this. If you've taken physics, you certainly do. So guys, if you would like an example of that, skip down 3 lines and let me give you an example. So guys, it looks like this. Imagine that you had to do a calculation where you had to multiply 125.50 times 2.3. So guys, how many significant digits in 125.50? Is the 0 significant? Is the 0 significant? Yeah, it's a final 0 after the decimal. So this has got 5 and this has got 2. So how many significant digits do you get in your answer? 2. So when you do the math, it works out to 288.65. But we need to round that to 2 significant digits because that's the fewest with 2. So this is 1 significant digit, 2 significant digits. The 8 says round up. So to 2 significant digits, this is 290 grams. That would be your answer. You okay? Okay. Now guys, I think most of you, if you've taken physics, knew that. Here's the one that's a tricky little fella. Addition and subtraction. I'm guessing a lot of you don't know this. Do you guys know the significant digit rule for addition and subtraction? You want to know why you don't know the rule for significant digits for add and subtract? Because there isn't one. This is the rule that you need to know. When you are adding and subtracting, you do not even care about significant digits. What you care about are decimal places. And so you can serve decimal places rather than significant digits. So let me show you what this means once you're caught up. So imagine, guys, that we take the same numbers, but instead of multiplying them, we subtract them. So 125.50 grams minus 2.3 grams. Now here, guys, we don't care about how many significant digits there are. Just do the math. So you subtract these, and it's 123.20. But that is not the answer. What you do is you look at decimal places. How many decimal places in the top number? 2. How many in the bottom number? 1. That means you get 1 decimal place in your answer, and the answer is 123.2. So guys, when you're adding and subtracting, we don't care about significant digits. We care about decimal places. Questions there? If not, we've got one more thing to do, and you can work on your homework. You guys good? Okay, last thing, guys, and we're done. This will be the last thing that you will, well, the first to last thing that you will do in lab on Thursday. You will gather up all your data and you will do calculations following the significant digit and decimal place rules. And then guys, when you're all done with that, you're going to figure out how well you did in lab. You are going to calculate what is called a percent error. So guys, percent error goes like this. You want to write this equation down. You need to be able to use this equation. So percent error, which is what you're calculating, is equal to this. Experimental divided by accepted. He's making it. Experimental minus accepted divided by accepted times 100. Now guys, what do the vertical bars in the numerator mean? Do you guys know? Absolute value, which means just make the answer positive. You will never get negative answers from this process. Yeah. Absolutely, yeah, and that's interesting. Because it's absolute value, you can switch them. You know, subtraction is technically not, what's the word for that? Where you can flip things around. Freedom, yeah. So technically you can't do that with subtraction, but because it's absolute value, you can. Yeah, and that works every time. So guys, what do these numbers mean? Well, the deal is this. The experimental value is your value. It's what you measured or calculated in the lab. Then the accepted value is the correct value, your goal. So guys, I'd like to show you an example of this. If you'd like to write it down so you have an example, that's great. But this is what we needed to do today. You learned all about how to use all the equipment that you'll need in lab. Then we talked about significant digit rules for multiplication, division, and addition, subtraction. Now you understand that the last calculation that you're going to do on Thursday is figure out your percent error. And you do that with this equation. We'll look at an example, and then you'll have time to get your homework done. Can I show you an example? Okay, if you'd like to write it down, you can. It's up to you. So guys, next time in lab, say that you expected to gather up 2.85 grams of product. But say that you only did gather up 2.25 grams of product. You didn't get back as much as you thought you would. So how bad did you do? If you thought you were going to get 2.85 and you only got 2.25, how bad did you do? Well, guys, the calculation looks like this. And we're going to say this once, and we're never going to say this again. The answer is yes. Anytime you use an equation in this class, you've got to write it down. No exceptions, no excuses, no apologies. So guys, every time you use this equation, you write it down. You'll learn that quickly as you just keep losing points because you're either thick-headed or stubborn. So guys, you've got to write, or lazy. You've got to write it down every time. So guys, which one is our experimental value? Is that what we got or what we should have got? What we got. And what did we get? 2.25 grams. Now the accepted value is what we should have got. And that's the 2.85 grams. And then guys, we divide that again by 2.85 and multiply by 100. Now, what do we do first? The subtraction or the division? The subtraction. But guys, be careful. How many significant digits in 2.25? It doesn't matter. Because you're subtracting and you don't care about significant digits, you care about decimal places. So we've got 2 decimal places and 2 decimal places. So how many decimal places do we get in our answer? 2. So the answer to that is 0.60 grams. But wait a second, 2.25 minus 2.85 is negative 0.60 grams. Why did I make it positive? Absolute value. Now we divide by 2.85. Now, how many significant digits in 0.60? 2. How many significant digits in 2.85? 3. How many significant digits in 100? Doesn't matter. Guys, 100 is not actually a part of this calculation. All it does is convert a decimal to a percentage. So this does not limit significant digits. So we've got 2, we've got 3, we've got doesn't matter, and when you do the math, it's 21%. So you lost 21% of your product. And let me tell you right now, guys, you will not be graded on your percent errors yet. Later in the year, you'll be held accountable for getting low percent errors. Right now, it doesn't matter. You okay? Okay. So guys, grab your homework.
What's like a good percent?
Depends on the lab. Depends on what we're doing. So guys, we've got about 20 minutes, which is precious time for you because you can work on your homework. So guys, take a look at it with me. It is the 3rd page in your homework packet, and you'll notice that it also goes on to the back. Okay, so let's talk. Guys, and seriously, I want your feedback here. There are 7% error questions on the front of this paper. Do you need to do all 7? I'm thinking if you can do 2 or 3, you can probably do all of them, right? So, let's do number 7. What if we just do numbers 1 and 7? So guys, let's do this. We will grade numbers 1 and 7. If you want more practice, you can do the rest. But we will only grade 1 and 7. And guys, let me tell you right now, when you set up your problems, make sure you're putting units on your numbers. Then on the back, we will, of course, answer all 9 of these. So that's your homework. Now, guys, before I cut you loose, I want to talk with you about one thing, because I was really hoping that at least one of you would say right now, hey, wait a minute, don't we have a quiz today? Because you guys are checking the calendar, right? And on the calendar, it says lab procedures, percent error, and quiz. You should, right now, in the next 20 minutes, be taking the follow-up quiz to the one that you took before. But guys, yesterday, Miss Call and I decided to change the calendar. And I want to share this with you really quickly. So guys, this is what we've decided to do. We took the quiz away from today. Here's why. If you go over here and if you look at September, which is when I will see you next, on Thursday we are going to go to lab. You'll be in lab. For those of you that were not here on Friday, we need to talk right now because we've got to make sure you're in lab groups. Then guys, when I see you on Tuesday, we are going to have a day that is not traditional instruction. On Tuesday, you are going to have the follow-up quiz that's just like the quiz from the first day, different numbers, and it goes on your grade. And then, guys, in addition to that, Miss Call and I decided to take a long period of time to introduce to you your first investigation project. In this class, we do investigations with every unit, and these are big multi-day projects that you will be doing in groups. And because this will be the first one that we will do together, we'll spend some time on Tuesday and we will talk about what that's going to look like. Then when I see you on Thursday, we will cover the last of the new material for this unit. We'll go over metrics and density. Then when I see you the following Monday, we will do a lab over that concept. And then guys, the following Wednesday, the 14th, is your test. So that's the rest of the unit. So guys, here's what we need to do. We're done. You've got the homework in front of you. We're just going to do 1 and 7 and then the back. I will put the answers on the wall. Again, you're welcome to grab your cell phones if you want to look at the answers. And then for those of you that were not here on Friday, come talk to me right now.